Right. Hello, everyone, and welcome back to the second day of Dialogue 20 Online. I hope you're all well and ready for another half day of presentations from us at Dialogue and from a couple of our users as well. My name is Morten Kronberg, and I'm the CTO of Dialogue. I am about to spend 45 minutes entertaining you with one of my favorite pieces of technology, and I hope I'll be able to rub some of the enthusiasm off on you. It's always a bit daunting with these presentations where you know that there are people in the audience who know far more about the topic than you do, and at the same time there are people who are going to really struggle to keep up, but hopefully I'll be able to find a medium and everybody can follow. Right, so I'm going to be talking about what we call Dialogue's public Docker containers. First, I'm going to very briefly introduce containers, hope not to spend too much time on that, but then talk about the 5 or so public containers that we've decided to offer you to help you get started with containers and show you how to start them, stop them, debug them, extend them, and how this is one of the things that I find really attractive about Docker, is that it really allows you, if you want to build a multi-tier application, or you want to separate your application into parts that are easier to maintain independently, it really has tools to help you do that without losing track of what you're doing. So you'll see this whale here, which is carrying containers on its back, and what we're going to do is try and put APL containers onto the back of the whale, hopefully not into its belly too much. So what are containers? Well, here are some various types of containers. In our context today, a container is a mechanism for partitioning a computer, a host computer, so that multiple applications believe they're running alone on the machine. Now, you might say, well, isn't that what virtual machines do? And in fact, this is very similar to virtual machines. But containers are much more efficient. And I'm going to try and illustrate that with a picture here. If you look on the left, you have the layout of a typical machine hosting virtual machines. And on the right, we have a container machine. And at the bottom, we have the server hardware and the host operating system. But then the difference is, in the virtual machine, you have something typically called a hypervisor, VMware, for example, from Oracle. And then for each virtual machine that you start on the server, you load the entire guest operating system. You see these large purple blocks here. So if you wanted to run multiple virtual machines running Windows or Linux, you would load the operating system multiple times. And then you would have some libraries on top of the OS. And finally, your application is this little blue thing at the top. Whereas on the Docker side, on the right, the Docker engine manages to isolate the applications from each other without having to run multiple copies of the operating system. So if you're running Linux, for example, you can even run different distributions of Linux, and they are implemented just with this thin yellow-orange layer of binaries and libraries. The host operating system, the kernel of the host operating system, is shared by all of the machines. And what that boils down to in the end is lower costs. So because you need less hardware to support the same number of applications, the applications are using all the resources on the machine rather than the hypervisor and the multiple copies of the guest operating system. The other thing to me sort of that really makes containers attractive is that where you set up a virtual machine, you install a copy of the virtual machine and the applications that you need, and then you discover that the disk was too small, you repartition it, and a couple of days have gone by before you have a working machine. With Docker, you just have this very simple text file that completely describes the container, which is created from scratch each time you start it. So you have typically a from statement, which says what the base image is. Typically, that'll be some Linux distribution. It could also be a Windows container base. Then you add some files into it. So these would be typically files that you have on your machine. In this case, I'm adding a version 18 installer package and loading it into the root of the container. I then have the option of running some commands while the container is being built. So in this case, the first dpkg installs Dialog APL. And the second statement there does a git clone of the Jarvis GitHub repository. I'm imagining that I'm creating some kind of container similar to the one, our public Jarvis container, which contains Unix, Dialog APL, and the Jarvis web service framework. Finally, I have the option of setting some environment variables, and then I can specify a command that's going to run not during build, but when the container is started. And once I've built the container, I start it using the docker run command. So I'm saying here, docker run with an interactive terminal, mapping port 8080, run the Dialog Jarvis container. And that starts a virtual machine in a split second. I'll show you that running a little bit later in the presentation. So the number of switches here, I'll spend a little bit of time explaining the ones that are really relevant when you're using the Dialog containers. So the first one there, the -IT is combining the I and T switches to allocate a pseudo TTY and to keep standard input open, even if there's no terminal attached. And that's something we're hoping to eliminate. It's a requirement of current Dialog APL up to version 18, but it gets quite unhappy and you have trouble attaching RIDE, for example, if you don't have an interactive terminal. So until further notice, just accept that you're going to want to put -IT on every single docker run command. Next, we have the P8080:8080. What that does is the first number is a port number on your host machine, so my Windows machine in this case, and the second number is a port number on in the container, and it opens the firewall if you like. If you don't have any of these -P switches in your command, the Docker container will be completely closed. It'll be running its own network maybe, it'll be able to do things inside the container, but nobody outside is going to be able to interact using sockets of any description with the container. So you're pretty much always going to want one of those if you're going to use the container for anything. There's the -V switch, which mounts a volume. And what that does is it specifies a folder in your host machine. So my Windows machine in this case, imagine I have my application in /my/app/folder, and I want that to appear as /code inside the container. So this is irrespective of how the container was built. So this is a dynamic mapping where a folder in the host machine is dynamically shared with the container. So if the container were to modify any of those files, they would also be modified on my Windows machine or my Linux machine or my Mac, if that's what I had. All of what I'm showing you here now works in exactly the same way on Windows, Linux, and Mac OS. And you can set dynamically environment variables. So if there was an environment variable like typically RIDE init to set up your container for attaching RIDE, you normally wouldn't put that into a container because it's something people would want to decide dynamically, whether they want to allow debugging. So you can set, well, you can set any environment variable. The one I typically set is RIDE init. And of course, if you set RIDE init, you must also open a port. So the -P 4502 says, let the 4502 port, the RIDE port, out through the firewall as well. And that's a very common mistake I make, is to forget that, and then I can't attach RIDE and I sit there scratching my head. So here's an example of my having typed docker run interactive terminal, mapping in a Jarvis sample folder into the code folder of the Jarvis container. And you can see the first line of output there says unable to find image dialog Jarvis latest locally. By default, it looks for the version tagged as latest. And it then goes off to Docker Hub to download the container. So you don't have to, before doing Docker run, you don't have to download the containers. You can just rely on Docker run to go off and get public containers or private containers if you provide a user ID and a password. And then as soon as it's downloaded, we can see it says already exists. That's because presumably I had some similar containers loaded. Docker is very clever about detecting whether layers of other containers that are the same, so that the basic dialog container, for example, that the dialog Jarvis container is built on was already here. So it just pulls down what it needs, and then it starts the container. And if you've looked at Jarvis at all, you'll know that you can direct a browser to port 8080. You can type the name of one of the functions or methods that's exposed. You can provide a JSON payload, the 1031 here, 31st of October, Halloween, and click send, and then you can see the output from running that function. So what Jarvis basically does is it takes a JSON payload, converts it to an APL array, calls the APL function, gets a result, converts it back into JSON, and returns it. That's what Jarvis does, and that's what you can very quickly get up and running with the Jarvis container. There's also a getSign object, which instead of a 2-element integer array takes an object with a month and a day property and returns day and month, and the sign as a property, as an object, if you're using a language where that's more convenient. And we can see the definition of getSign object is just to call getSign that we saw before, extracting the month and the day property from the object that was passed in. Okay, so this is part of the sample JSON application, which is shipped with Jarvis. So in fact, if you start Jarvis, you don't have your own application at all. You'll just get this one, which has these 3 methods, getSign object, and getSign with request, which shows how to use peer certificates if you have a client that's connected securely using a certificate. Now, if you wanted to call the Jarvis service from APL rather than using the browser, there's a utility called HTTP command, which you can load using bracket load. And then there's a getJSON method, which is specifically designed for interacting with JSON style servers. So you can say post to localhost port 8080. GetSign is the name of the resource, which is mapped to the function, and the 2-element vector. You get back an object which has a return code, a message, an HTTP status, and the data, which has been converted back from JSON into an APL array. So that's a little bit about Jarvis. So if you want to know more about sort of basic details about Docker using APL with Docker, I've done 2 presentations earlier, and if you're in any doubt as to whether I've drunk the Kool-Aid, I have. I think this is amazing. It's one of the few technologies I get to work with where I just have this little grin on my face. Every time I type something, it either works or I get an error message which tells me exactly what to do next. That's my experience so far anyway. So the topic of the presentation is these public containers that Dialog has decided to publish rather than just allowing you to build Docker files like the one I showed you to begin with, where you start with Linux and then you copy in the Dialog installer and do the installation. We've decided we should give you a leg up. And in fact, that's one of the really beautiful things, again, about Docker, is that you can layer containers on top of each other. And each time you do that, you just make it easier for the next person to build an application. So Dialog is the name of our organization, and then there's the Dialog image, which is just a minimal Linux Debian Buster Slim. Some of you may know what that means. To me, it's just an absolutely minimalistic Linux with Dialog APL installed. Dialog Jarvis is this one we've been looking at so far. So that's in addition to Dialog. It has the Jarvis service. There's a Dialog JSON server. So JSON server is a sort of half of Jarvis, predecessor to Jarvis. So that's really deprecated. If you're using JSON server today, I recommend that you move on to Jarvis as quickly as possible, because that's where we'll be investing our energy. There's my server. So you can, if you want to write web applications using my server, there's a, it's very easy to get started. You just need to add a few functions, as we did with Jarvis. And then there's a Jupyter notebook. So that has the Jupyter kernel with the Dialog kernel for it, making it very easy to get Dialog-based Jupyter notebooks up and running. If you go to hub.docker.com/u/dialog, you can see all of the containers that we have made public. I think there's a little bit of cleaning up to do here after the user meeting. There are a couple of containers that like the CentOS 7 build, which perhaps shouldn't be public, but basically it's the list you've just seen. Or if we leave them public, we need to put some explanation of what they are. So if you click on one of those, you can get a bit more information. The information is still rudimentary. That's one of the things we really want to do with version 19, is to provide more information about how to use the containers than we currently have. I see there's a question from Kai Jäger about which version of Dialog you have in the containers, and that's a question that I will get to in a moment. Right, so we're effectively putting copies of Dialog APL out in the public domain here, and the responsibility is yours to ensure that whatever use you put it to, you have the correct license. And if you build Docker images on top that build on top of ours, you should include information in the description of your Docker containers if you make them public, so that anybody who uses the container realizes that it's free for non-commercial use, and so on and so forth. Ideally, a link to our licenses. If instead of going to our homepage, you type Dialog in the search box, you'll see our stuff at the top, but you'll also see that there's a small group of people who have started building containers on top of Dialog APL. So here's an example of somebody who wanted to use Dialog APL on Gitpod and decided that a container with Dialog APL RIDE Acre 602 was a nice base for whatever application they were building. Now, each one of the public containers has the notion of a default folder where it will look for an application. So if you load Dialog, the basic Dialog application, it will look in a folder called app. And if in app it finds a single workspace or a single APL function as a text file, a .apla, or a single class or a single namespace, it will run them using the load parameter that version 18 supports. The Jarvis container, when it starts, will look for a folder called /code. And if that folder exists when APL is launched, it will start serving that as a service. JSON server also used /code. The my server component looks for a /mysite folder. And I believe the Jupyter notebook also looks for /app. I didn't have time to test that before putting this together. So If you want to use Jarvis with your application, you need to use one of these -v to map your application folder wherever it is on your hard disk, and map it into code. And that's all you need to do to have the Jarvis container auto start with that. When you want to stop a container, well, the obvious thing to do is to implement some kind of shutdown method in your service so that it terminates APL cleanly. The container will shut down when the main process that was launched terminates. You can connect RIDE and type off, or you can, so this is a window showing that we've started a Jarvis server. If you hit Control break, you get a prompt. This is going to happen to you eventually, that something terminates in such a way that the container is left running. There's a Docker, excuse me, PS command where you can get a list of the currently running containers, and you'll see they've been given these interesting names, like in this case, Kind Shockley, and you can then type docker kill Kind Shockley and the container will be shut down. I noticed when testing this, something that didn't work this way last year when I looked at it, that if you hit Control C instead of Control break, there was a little pause, and then APL apparently caught it, tried to enter the tracer, said that the editor could only be used within a session, and left me in the APL session. And from there I could type paren off, and then there's no container running at the end of that. Now, here are the answers to the couple of questions that have been asked so far. Which version of APL? What about .NET Core, etc.? So the containers, like dialog, have tags the same way that you would tag releases in GitHub. So if you don't specify a tag, you get the latest tag. But at the moment, we have these 3 tags for the dialog container. I didn't research exactly which tags we have for the other versions, but for the other containers, sorry, but you can find that out easily by going to Docker Hub. So latest is latest. 18.0, 17.1 are specific releases of Dialog APL. And we just added one a few days ago called .NET Core, which is still a bit experimental. That will probably be split into an 18.0 .NET Core and a 19.0 .NET. Sorry, it won't be .NET Core anymore in 19, will it? It'll just be 19.0 .NET. And the way you select a tag is, you can see in red here, you put the colon and then the tag after the name of the container. So here we've gone to the dialog repository and clicked on the tags tab, and there you can see a list of the tags. We've got latest, which was pushed 4 days ago. You can see it was pushed by something called Dialog Jenkins, which is our build system, which built the container and then uploaded it to Docker Hub and the .NET Core and 18.0. So now, if you want to these it sounds a bit daunting with these boxes that are sitting there, but it's actually quite easy to debug them. All you need to do is to set a RIDE init environment variable, assuming you haven't launched a runtime container, of course, which doesn't respond to that. We haven't created any runtime containers yet. That's one of the things we need to do for version 19. And you have the option, if you have RIDE installed, you can set RIDE init to serve, * means accept sockets from any location. 4502 is the port to serve. Or you can set it to HTTP, in which case the RIDE or the APL interpreter will serve RIDE up. I should have had a DOS window open here. So this is where I try to go live and everything comes unstuck. So if I say docker run ite ride init equals serve. Actually, let's just only do one of them. We'll only do the zero footprint. So 4502 minus p 4502 4502, and we will start the. Let's just do the Jarvis. Have I forgotten anything? I shall soon find out. There it started. So this is one of the things that John is working on in the scripting and the IO, that we'll be able to control the look and feel of this IO a bit better. So I'm starting a web browser here, and I'll direct it to localhost 4502, and zero footprint ride is a feature where the interpreter itself acts as a simple HTTP server and downloads all of the source code for ride, so that you can use it from a browser without installing ride locally. That's why it's called zero footprint. So now we have ride, we could do any debugging that we need to do, set stops and traces and debug it if it had crashed, or type off and stop the container. Everything works the same way under Linux. I've said that already. In fact, a Docker desktop for Windows used to be this nasty little thing that sat on your machine and consumed lots of CPU even when nothing was going on. And as I started preparing for this this talk, one of the first things that happened was I got this wonderful pop-up here, which sounds pretty ominous. But what it was doing was uninstalling the old Docker desktop and upgrading to the Windows subsystem for Linux. So it installed Linux on my Windows machine, and the system is now wonderful compared to how it was with the old Docker desktop, because everything's happening in WSL, and it really, really works well. So this is my Windows machine, and I can type Ubuntu, and then I get this window where I can type Docker commands. Let's see, what do I do here? I said Docker run, yada, 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 and then I used the .NET Core tag and HTTP. I then connected to it. You see, it's not localhost, it's this number here, which is the WSL system. WSL2, Kai Jäger says, hopefully. Yes, this is WSL2. And then, as you can see in this very simple example, I set quad using, I can get the OS version. It's happened what I think I predicted in one of my keynotes a couple of years ago, that there would be a Microsoft Linux. This system identifies itself as Microsoft standard, and we've got auto completion and stuff working with .NET. Beautiful. Now, as I said, one of the really nice things about Docker is that you can easily extend the containers. Typically, you extend them with your code. You could extend them with data, but normally you would map the data in at runtime. So what you need to do then is, so I've got this folder. It's got my own version of getSign, and I've written a Docker file, which is just these 3 lines. It says from dialog Jarvis, set the code location environment variable, which Jarvis looks for to say the code is in /myzodiac, and then add the contents of the current folder and call them myzodiac. And then I wanted to name the signs differently from the default version. So some more, down to earth, understandable names of signs. And you see here, I've done at the top, I've done a Docker build. The -T says how to tag, what name to give to the container. And then you can see the lines running. It says successfully tagged M. Kronberg myzodiac : latest. And now I can refer to M. Kronberg myzodiac, and instead of the default Jarvis, we get this one here, where instead of Aries, it says RAM, so I can understand what that means. Now, if I wanted to make this container available to all of you, which in fact I have done, I say Docker push. You have to have a user ID on Docker Hub to be able to do this. And if you want to have more than one private repository, you have to pay them some money, I think about $5 a month. You say Docker push and the name of a container that you have built, and it pushes it off somewhere. And then you can go on to, this is a Ubuntu Linux machine running on Amazon Web Services. I can go over there and I can say Docker pull, and it brings it in, and I can now run that container on some completely different machine or some different operating system in a different part of the world. Right, so that's, yeah, that's the basic thing about the containers and how you can easily extend them. Now, one of the things that is really cool, and I'm really enjoying at the moment because I'm actually building a web application, is that you can set it up, you can have collaborating containers. So what I'm going to do here is I'm going to use QWC, which you'll see a more thorough demo of a bit later today when Chris and Michael show you that. And I've collected into a folder HTTP command, which you saw before, because I want to call, my code is going to call a Jarvis-based server. And I wrote a function called onloaded, which if you've done any QuadWC programming, you'll be able to read. It creates a form and some labels and a date time picker and a button with a callback. If you click on the button, it calls something called do Zodiac. And when that runs, I think I'm going to run out of time. I won't be able to show you this running, but it creates a form that looks like this. And then if you click on the button, oops, I've modified my slides at the last minute. So the callback, again, if you know QuadWC programming, this is all very simple. It does the same get JSON call that we saw earlier, and then depending on whether it was successful or not, it either outputs an error message or it updates the label with the name of the sign of the zodiac. So I decided that a nice thing to do would be to take the folders that Michael Hughes sent me containing the QWC code and create a container. So I said let me get back into presentation mode so everything's bigger. From dialog 18, copy the folder app CS_HTML5, which is the main body of code in QWC. Copy the index page and the Jarvis, which is embedded within QWC. I need to, because I'm creating this from Windows, I have some issues with performance. I have to, after I've copied all these files, set some permissions. And then I say when it runs, load the QWC startup workspace. So now to run my combination, my two-tier system, I start by running the my Zodiac container and exposing port 80. And then I start the QWC container by saying run mcromberg QWC, mapping my code into the user folder, which is where QWC will go to look for it, and a configuration file that you also need to do to set the port numbers. And then these are the default port numbers that QWC uses for the HTTP connection and the WebSocket that it is based on. So I could write some, a script or a batch file that would fire those up, but I discovered there's a system called Docker Compose, which makes this really, really elegant. So if you have a group of containers that need to work together, like the back service and the front service, you set them up. You say, okay, the back is going to be built from mcromberg my Zodiac, restart it unless a stop signal has been sent. Set this environment variable and open these ports. QWC is M. Kronberg QWC. Map these volumes, set this ride init variable, and open these ports. And then you just type docker compose up. And you see it magically start 2 Dialog APL applications. And let's see if I can get this to work. This is where it gets really exciting. So docker compose, I've got the, in here, I've got the docker compose YML. So I just say docker compose up and count to 5. I take my web browser, I direct it to 1234, which is the QWC port, and there's a bit of JavaScript and stuff that gets loaded by QWC, which usually takes less time than this. But actually, one of the things I've seen is that all of this software, when you're doing Zoom presentation, runs like mud. But of course, that's life these days. You can't really avoid that. So here's a date time picker. I'm going to pick a date at random, 5th of May, and click go. And it says, failed, cannot assign requested address. Darn. Now, I have an idea what's wrong with this. Let's go and have a look. So let's start a ride session. Yeah, everything is much slower with anything that has to do with GUI seems to be much slower. I'm going to connect on localhost, and I think it was 5502 that was the front end. And here we are. And if I have a look at the let's see, the do Zodiac. Yeah, right. So John, if you're watching this, you see the autocomplete didn't work there. And that's one of the problems we need to look at when running multi-threaded applications. So the problem with do Zodiac is that this was working fine on localhost, but in the Docker Compose, we named the backend container back, and it's not available as localhost. It has to be referred to as back when you're inside the virtual network that these two containers are running in. So by changing the name there from localhost to back, I can now get a bull out of this. So although I've created them, two things running at the same time with Docker Compose, it's easy to get in and debug them if you've enabled that. Of course, you may not want to enable that. That's your choice. So a couple more really interesting things about Docker Compose. It'll restart containers automatically if they fail. So I mean, a nice thing would, I put the ride init into the Docker Compose file. It would be nicer to make that something that's set using an environment variable so that you can easily turn debugging on and off. So you'd need a little batch file like this or a script file to set these environment variables, and then you can refer to them in the Docker Compose file. So some things can be dynamic. You could also make the volumes that get linked in dynamic using environment variables. And of course, some of you will have spotted that I exposed port 8080 in the Docker Compose file. So that's only something I would need to do if I want the Jarvis service to be available from outside. There are no restrictions on communication between the containers running inside the virtual network created by Docker Compose. So I can take that line out. That will leave the back end available to the front end, but will not have it visible from outside the Docker containers. So if in that debugging session I'd had before I typed off, then if you go and look at the log, you can see here's an off, and there's a failed to complete write of log file. So there's you know, some of the stuff that JD's looking at cleaning up. But then Java started in JSON mode again. So it immediately, when the process ends because of that startup command, it immediately restarts the container. And there's a whole bunch of things that Docker Compose can do that I haven't yet really learned to do. You can specify that it should start multiple copies of the same image. So if you suspect the load is going to be high on one of your components, like the back end here, I could have said, well, start 3 of them, or some rule to say when to start more if they're getting heavily loaded. And Docker Compose, with its virtual network inside the machines, will allow them, it will multiplex between them. They'll all think they're the only thing on port 8080. There are ways to find out, you know, which one you are and so on, if that's important to you. But it allows you to, as long as your stuff is stateless or you've done the work to share files between multiple processes, it's really very, very easy using Docker Compose to load multiple versions. And you know, it has tools to, I think, pull a new version of a container, and then sort of slowly switch people between the old version of the container and the new. Right, let's see. Oh, 3 minutes to go. Good thing we're near the end. One of the things that's really impressed me about using Linux, which I have sort of slowly learning to love, is that if you look at, this is a tool called HTOP, which shows the top consumers of CPU or memory, etc., on your machine. If you look at the CPU, so this is I think this is a Docker Compose cluster of 4 processes, a couple of dialog containers, something called Zapper, and a video server component. And there's nothing going on here. When the system is not doing work, the amount of CPU consumed is very close to 0, and the amount of memory used is, you know, it's only 466 megabytes. So this is really effective, efficient, cheap, fast software to be working with. Right. So, but you know, the containers have been getting better over the last couple of years, but we now have sort of this major piece of work that John Daintree talked about yesterday to rework the I/O handling so that we can support RIDE without this interactive pseudo TTY always being there, being able to manage the output to the logs and so on. We know that RIDE doesn't always work very well in heavily multi-threaded server environments. There's some work we need to do there. More documentation, open source demo apps, etc., to show how to build these load balanced applications secured with sockets, with certificates, and so on. Publish our Docker files on GitHub. They're not yet public. This is from our internal repository. And that's it. And with 2 minutes to go, I see that Alexei has a question demonstrating the .NET Core container. I believe I did that. Alexei, if you didn't see me do that, let's do that offline. Or go and review the presentation afterwards. And Kai asked about which version of Dialog APL it was. And I believe I have 1 minute left if you have any new questions. I see Michael Hughes is sending fake news out about new strains of coronavirus in Denmark, but it turns out they're all, they've died off. They adapted, or at least that's the current theory. They adapted to mink, and then they were not particularly successful on humans. Marco is asking about the source of the Docker file. Okay, so I believe that's really, I think we would be happy to share the Docker files. We will publish them soon, so we will do that. And I think my time is up. So I'll be handing over to Adam now. It's a 1:45. So thank you very much for following that.